Hi, welcome everyone to today's senseFly Academy session. So name is Andrea. I'm the training manager here at senseFly, and I'll be talking today about corridor mapping. In terms of corridor mapping, we'll talk through what corridor mapping is for, how a workflow looks like, and then even go into emotion and look at it in more detail, how you do the setup and what are the options. Then we'll also look at a sample data set in Pix4D, how to process a corridor data set and its results. Okay, so let's get started. What is corridor mapping? Corridor mapping is a mission block type designed for mapping linear features like pipelines, power lines, roads, train, river system, and I'm sure you guys come up with many more applications. Drone types that can be used are eBee Plus, eBee, and Albris. It's just a mission block type in the end. Special is though doing a mission block using the S.O.D.A corridor kit. It means that the S.O.D.A camera is mounted basically vertically into the integration kit instead of horizontally. This allows for a higher longitudinal overlap, and therefore we can generate data at a higher resolution. Means we fly even lower. The highest resolution we can generate is 1.5 centimeters per pixel. Pixel per centimeter. Actually, that's wrong. Okay, good. Um, Here's some more details. So basically what we're doing with the S.O.D.A corridor kit, we're just switching the picture format from landscape to portrait with reference to the flight direction. This eliminates some very, well, not so useful content in the image, and we have more longitudinal overlap, which, as I said, allows us to generate even higher resolutions. What is very nice about this feature is also that keeping the same overlap, so the usual lateral 70% and longitudinal 60%, allows us to generate a data set with less images, which makes then image processing faster, giving us the same quality of results, but also being lighter, having lighter files as a result as well. Okay, let's look at the corridor mapping workflow. First, of course, you need to define your project. The most important parts for a corridor mapping project would be the length of your linear feature and the width. Both of them can be set in emotion. It's nice to get plans or KML outlines, especially if those features are, for example, underground or not existing yet. Also, it's very helpful to know the resolution for your flight in advance, which greatly influences the flight time that you need. Then for planning the mission in emotion, you will need to know your working area settings depending on the local regulations of where you're flying. What is very useful to have is RTK PPK activated on your eBee Plus. It will avoid to having to collect many ground control points, and it also greatly increases the quality of the data set once processed. Up front, you can also already arrange your corridor block layouts in emotion. This is what we're going to do right after. And this also gives you, of course, an idea about your total flight time and the amount of batteries that you will need in the end. Don't forget to download the background map data and import those KMLs and plans in order to better define your mission blocks. For flying the mission, basically it's as usual, start and landing against the wind, enough space, weather conditions in general, and be aware of the sky. Just control your airspace. If you have someone entering your airspace in an aircraft or another drone, you need to be ready. processing. So after your flight, make sure you have enough processing power, especially if you did a very long mission. And also think about how to save and how you want to share those results, which could also influence what kind of resolution you choose up here. If there is no special requirement, it might not be useful to go for the highest resolution possible, because that just means that your data set is going to be very big and large and maybe hard to work with. Good. So let's look at corridor mapping mission based on a real world project. The object is the project RC177, a road construction here in Switzerland. It's a new road of 5,500 meters. It's going to have 2 lanes and it's 14 meters in width. The purpose is to enable economic development in the villages Bufflon, La Ville, and Aclan by establishing a better connection to the highway. The result should be a 2.5 centimeter per pixel orthomosaic. This is the plan, and the road goes all the way from here around and over. There's even a second plan for the rest of that road. Okay, so planning that mission. Working area, get authorization. Luckily, this project is in a very non-urban area, so there is not no many houses that are in the way. So in Switzerland, that means we can fly within line of sight, no special authorization needed. Um, we need to make sure that we have our RTK PPK activated on the drone and the stream set up, and we download the map data as well as import the KMLs or respectively that plan into emotion free. Here is the layout of the mission block type. So we're going to choose corridor mapping as the mission block type with a resolution of 2.3 centimeters per pixel, which is slightly lower than the 2.5, but we do this on purpose in order to really make sure that our result is afterwards in 2.5 centimeters per pixel. The road has a width of 14 meters, but actually we want a little bit of the sides. We want to capture a bit both sides of the road. Therefore, we're going to set the width to 50 meters. Flight time with a setup like that is going to be around 25 minutes, 24, 25 minutes. And for RTK PPK stream, we're going to use the SweetPost VRS, which is the service in Switzerland. Okay, let's do this in emotion. Entering emotion on the welcome screen. You want to select your drone. We're going to do this now with eBee Plus, and we're going to select the camera, S.O.D.A corridor, which means that the S.O.D.A camera is mounted on a corridor kit, therefore in portrait format and not landscape. We click on Create Mission, and you see my plan is already imported. This I did through Options, Feature in this case, but it could also be that you import it as a map. You could also import on top elevation data. This layer can be activated or deactivated here on the layer button and just turn off or turn on. Actually, we're going to do this demonstration around these two curves here. And you can see if I turn off my KML here, you see there is no road whatsoever. So if I don't have that plan nor KML, nothing, it would be very hard to set up this mapping mission. So I'll turn it on. Elevation change, you see we don't have much. It does climb a bit from the west towards the east. Okay. First of all, I'm gonna place my working area So somewhere here, get a bit bigger. Okay, place it again a bit down here. Okay, the ceiling in Switzerland would be 300 meters even, but I actually don't need more than 150, so I'm gonna just leave it like that. Then I would download the map data. I'm not gonna do this now. In Emotion Free, you know by now probably that it will download the area based on the size of the working area, including a margin of 300 meters by default, which you can also change in the options. Then we go on the mission planning tab, where on the drop down we now select corridor mapping. And we're gonna start down here, zoom in a bit. So one place is basically point by point. You see, I didn't click and it gave me a whole polygon. We're gonna place now section by section. Voila. If you at some point lose your cursor to place any sections, it's simple. You just click on the left-hand side here on Add New Section. Voila. So if there are turns, it's better to create one or the other section more, but too many sections is not very practical either. Okay, let's see. That's maybe a bit far. So even now that I'm maybe not so happy with what I did here, I just move here my point a bit higher up and it automatically adjusts. I go back into the properties of my block here and I can just keep adding sections. Voila. So with this, we created 12 sections. It's maybe a bit too much. I could have been a bit, yeah, more precise down here. Check this. You can also go ahead and delete a section if you're not happy with it. For example, we could just start it out here. Voila. Okay, so that's for the layout. Now, of course, we need to define all the parameters. So name, I could name it, but I leave it now. Block 1 is good for me. Camera, I have S.O.D.A corridor, that's perfect. Plan above elevation data, yes. And the width we want to be at 50 meters, we said before. And the resolution we want to be at 2.3 centimeters. Okay. Lateral and longitudinal overlap, we can leave as is. There is no need to change that. If you stay around these altitudes, that's just going to be fine. Okay. Now, moving quickly away from this project in order to show you some more options that you have. You see here, we have a bit a steeper slope. So I'm going to just create one more block here. It's going to be outside of the project, but it's more for the purpose of showing how this would work if I would set up my mission sort of this way. Now I want this to be maybe a bit more than that. Okay, so on my second block here, it really starts climbing a lot in like this is very steep. And if I stay, of course, with the flight line set up above elevation data here, it's just going to be sort of flat and therefore I'll be at different distances from the ground, which will create images with different resolutions. Now what I can do is for a specific section, I can just go into the sections parameters and click on perpendicular lines, and it will automatically adapt the lines for that section to be perpendicular to the corridor that I placed. And you see, if I placed my corridor here going up the hill, then it automatically adapts it to the difference of elevations in order to stay at the same distance from the ground. Okay, so I don't need this anymore, so I can delete it. Voila. Okay. Now, once we're happy with our mission plan here, of course, I'm not going to go outside now, but we can simulate and also set up our RTK source. Okay, so I connect to my eBee Plus. Okay. Now, of course, it will for my RTK PPK in the simulator, you have to go on the parameters tabs and select activate upgrade for simulator. This will give you your RTK PPK tab on the left hand side there, and you can set up your sources so you're more ready once you're outside. That will be either for the base station, any reference points you already have, or your VRS connection. This is already done for me, and if the stream is free at the moment, I hope to set it up right now. Let's check. Yes, it worked. So the format RTCM free. We have GPS and GLONASS OK. You see we have the little station here. It's very small, but it's simulating a base station. And on the right-hand side, we have under GNSS, it tells us that we have a very high accuracy of 0.7 centimeters, and the mode is RTK fixed. In order to place start and home, well, I could change here the position of my drone. Maybe I think I'm gonna be around this road corner here, because here I could leave my car, putting the drone outside, plugging in the battery, and now I can place my start and home waypoint based on the drone's position using the notification here on the left-hand side. Voila. Now, of course, I would want to avoid to cross this long road. Of course, that's just an estimation, because once you're out in the field, you want to evaluate all this again, but it's good to get sort of an idea of the environment where you're going to start and land your drone. Okay, and with this, go on the mission tab, we assign that corridor mapping block to the drone, and we are ready to launch. Caution, motors will start spinning. I'm gonna speed this up now for demo purposes, but as I said, during the flight, there's basically nothing else to do than watching the drone, watching emotion, keep an eye on the battery levels, on the wind speeds, etc. As usual, there's nothing special about it in the end, unless you do any BVLOS setup. Means you're flying out of line of sight. You might need additional people with radios in order to communicate with you, etc. But that would have to be authorized by the corresponding department in your country. Same as for any other mission block type, it's registering here the progress of the mission. Means At any point in time you have to land or change the battery, it will keep that progress and you can just resume the mission after you're ready again. Okay, that's too simple. So let's assume we already finished and we would go on and do Flight Data Manager. Let's just disconnect. Flight Data Manager is going to be all the same as normally. If you didn't manage to have an RTK stream, potentially you could do PPK, so getting your Rhinex reference files and adding them here in the process of Flight Data Manager. Now let's look at a potential result of this kind of a mission. You see it's actually exactly that road that we were flying in a simulation mode right now. Okay, so there is no special magic to this. In terms of processing options, you can just go ahead and use the 3D maps templates, giving you point cloud, mesh, orthomosaic, and digital surface model. If you manage to do this in one flight, then eMotion will create for you directly a Pix4D project. If not, you just create a new project here, giving it all the geotagged images, and with that, you'll be fine. Potentially, if you manage to do RTK PPK, it's not necessary to do any ground control points. Maybe it would be interesting to lay out one or the other checkpoint to actually evaluate your accuracy. You see here, this is now the point cloud from the second step, the densified point cloud. We said before that the project result that we are interested in is actually an orthomosaic at 2.5 centimeters per pixel. And you see that the output here is very nice. We exactly recognize where that road is being built, this bridge here that is being built. So actually just straightforward. And you can do this also with a normal, with S.O.D.A on the normal camera kit or normal integration kit or with a different camera or with Albris even. Just if you don't use any RTK or PPK correction, be aware to lay out some ground control points in order to avoid like bending or tilting in the data set, which can happen during the processing because of the narrowness of the project. Good. So thank you for joining senseFly Academy today. I hope to see you on the next session. And yeah, stay with us if your questions haven't been answered yet. Thank you. Have a nice evening, afternoon, or morning. Bye.